Hello everyone, welcome! This educational channel expounds topics in mathematics, civil engineering, and professional education subjects. This channel aims to simplify the lessons, and I am its founder, Bert, a Filipino licensed teacher and engineer. Thank you for watching.
Hello everyone, this is the second video on equations with homogeneous coefficients. If you did not watch yet the first part, please watch it prior to this current discussion. Let us solve example 1 using the other substitution x is equal to vy. Our purpose of solving this problem again with the use of the other substitution is to compare their solutions. Which of the two has easier solution? As you notice, we have here the substitution x is equal to vy. The derivative of this equation, the derivative of x is dx, then derivative of vy, using the product formula, we have v dy plus y dv. In this equation, we are going to substitute x by vy and our dx by v dy plus y dv. So we have here, instead of writing x here, we have here vy. So the x here is also substituted with vy, and our x here is substituted with v dy plus y dv. After the substitution, we simplify. Again, as noticed, we divided the equation by y so that the variable y here will be deleted, one of the variable y. So the simplified form, we have v minus y dy minus v plus 1 times v dy plus y dv is equal to 0. After this, we separate the variable, that is the dy is written with the y variables and the dv with the v variables. So we come up here. And as noticed, after that, we integrated. So for the integration, similar to our previous example, this rational fraction is being divided. So we have come up with v, this one, over v squared, and we have here the 1 over v squared plus 1. After which, we integrate. Similar also to the previous, we introduce a correction factor of 1/2. And integrating the equations, so the first term, we have ln of y. Second term, we have 1/2 ln of v squared plus 1. In short, the first two terms, we use the ln formula. And the third term, we use the arctan. So this is our answer. And this is not yet the final answer because we still express this in terms of x and y. Again, before substituting the value of v into x, we simplified the equation. In simplifying that one, we condense the ln term. So, grouping that one, this ln terms, we come up with this. Very similar to our previous, that we have here the arctan of v. After substituting, this is now the time for the back substitution, in which our v is equivalent to x over y. Again, this is just taken from our substitution, that is x is equal to vy. So v squared here, we substitute, that is now x over y. Then simplify, we have now this answer. Then when using y is equal to vx, this is now the answer. And if we are going to compare the two answers, we notice that the two differs only by the sign of the arctan. When using x is equal to vy, our arctan has a sign of positive. But then, if we use y is equal to vx, the arctan is negative. However, take note that their angles are reciprocal. The angle here, when x is equal to vy, the angle here is x over y. But when using y is equal to vx, the angle is y over x. And take note that arctan x over y is equivalent to the negative arctan of the reciprocal of the angle y over x. So therefore, the two answers are equal. As noticed, our two solutions have the same length of solution and are equivalent in terms of easiness. Now, let us just summarize the steps that we come up. The first step here is we substitute either y is equal to vx or x is equal to vy. After the substitutions, we simplify and we come up with a problem that is variable separable, meaning our variable v and y can be separated. With this equation, we integrate and we come up with an answer, in which our answer is in terms of v and y, which is not yet in terms of x and y. Therefore, we have the back substitution. Then after this back substitution, we simplify and we come up the final answer. So in short, we have only three major steps. Again, our major step, the substitution, then we solve it using the variable separable, and then we do the back substitution. At this time, let us try to determine when to use x is equal to vy or y is equal to vx in our substitution. In our example 1, as we said, the two substitutions have the same length of solution and the same in terms of easiness. Now let's focus example 2. So the equation x minus y dy minus y dx is equal to 0. Actually, comparing the example 1 and example 2, I just remove here the x. Now we have now negative y dx. When we substitute y is equal to vx, along the solutions we have here binomial multiplied by binomial. When we substitute x is equal to vy, we come up binomial times monomial, then we have binomial times monomial. So comparing the two, we will have a hard time to multiply this binomial by binomial compared to the other solution. So therefore, what is recommended here is substitute x is equal to vy. And if we are going to compare to our example 1, we notice in our solution, for the substitution y is equal to vx, we have here binomial multiplied by binomial. In our another solution, x is equal to vy, we have also binomial multiplied by binomial. That's why the two will have the same length of solution. So let us just try to determine here which of the two will be used for our example 3. So here we have the x squared minus y squared dy, and we have here xy dx. To have a simple solution, this dx is our focus to be substituted with a binomial, so that we have only a binomial multiplied by monomial. So therefore, our substitution from this one should be x is equal to vy. So that we have here the dx that is equal to v dy plus y dv. So we will come up here only with a monomial multiplied by binomial. If you will substitute the other, that is y is equal to vx, of course, you will come up here with binomial multiplied by binomial. So it is recommended that you will use x is equal to vy. And talking of example 1, As we mentioned, the two have the same length. But of course, even if the two have the same length, there is still better than the two. Oh, for example here, this is a binomial and this is also a binomial. But take note, the expression here contains of many numerical coefficient, that is 2 and 5, but here it contains only of 1 as numerical coefficient for x and y. So therefore, it's still recommended to substitute the dx here for simple solution. So it's still recommended here, substitute x is equal to vy. So that is now the solution for the equations with homogeneous coefficients. Furthermore, let me emphasize that the given differential equations in our examples are in the form of mxy dx plus nxy dy equals 0. In other words, the dx and the dy are already in the numerator. Just like in our example 1, you have here x minus y dy and x plus y dx. So again, dy and dx are both numerator. This is the form in which we can determine either the equation is a homogeneous or not. So if ever the equations will be written in other form, for example here, the given equation is written also as dy over dx is equal to x plus y over x minus y. In this equation, we cannot determine yet if this is a homogeneous or not. So, we have to convert this equation into the form of mxy dx plus nxy dy. Specifically, again, you can multiply this equation by dx to cancel the dx here. So this is now dy is equal to x plus y and dx over x minus y. And then you can also multiply this one, the equation, by x minus y, so that this denominator x minus y will be cancelled. So finally, you have here x minus y dy is equal to x plus y dx. In conclusion, I just convert back this equation containing of dy over dx into the given or original equation. So, when you already converted this form, you can now identify either this equation is a homogeneous or not. Remember also that this given equation, instead of writing dy over dx, this can be written by y prime. So you have y prime is x plus y over x minus y. Or this can also be written into x minus y prime is equal to x plus y. Again, the form 3 and 2 can also be converted back to the original given equation by substituting the value of y prime, in which the y prime here is equal to the dy over the dx. So once you are going to substitute this dy over dx to the y prime, then simplify to come up with the original given. And that is how to solve the differential equations with homogeneous coefficients. At this time, we will assess our learning. Our assessment has two parts. The first evaluates us in identifying an equation with homogeneous coefficients. The second test is finding the solution. For each test, you will be given a time to answer, and then the answer will be given later. So this activity is equivalent to more examples. Let us now start the first part. Which of the following equations have homogeneous coefficients? There are 5 differential equations and you are given 20 seconds. We are now going to answer. For number 1, for the dx term, x squared has a degree of 2. For the dy term, x squared has a degree of 2 as well as the y squared. So all of these factors have degrees of 2. Therefore, this is homogeneous. For number 2, the dx term has a degree of 1. But for the dy term, we have y here and a constant. Y has a degree of 1, but constant has a degree of 0. So not all of the terms here have the same degree. Therefore, this is not homogeneous. For number 3, our dx term here has a degree of 1. Then y here has a degree of 1 as well as x. So all terms have degree of 1. Therefore, this is homogeneous. For number 4, our dx term here has a coefficient of x squared. The degree is 2. For our dy term, the coefficient is xy minus 5y. xy has a degree of 2, while negative 5y has a degree of 1. So not all of the terms have the same degree. Therefore, this is not homogeneous. For number 5, we have here x squared dx plus y squared dy. Our x squared here has a degree of 2 and y squared has a degree of 2. Therefore, this is a homogeneous. By the way, take note that in finding the solution, homogeneous equations are converted into a variable separable problems. The conversion is done by substituting either x is equal to vy or y is equal to vx. Therefore, if the variables in a homogeneous equation can be separated, you must use the variable separable and not the solution for homogeneous equations. Otherwise, you are just complicating the problem. Now we are going to identify which of the homogeneous equations here is a variable separable. So we are going to identify here which of the homogeneous equations here are variable separable. For number 1, our dy term here, x here or y cannot be split out. Therefore, this is not a variable separable. For our number 3, y minus x here, the variable y nor x cannot be split out. However, for number 5, you notice our x squared here, and you have here the y squared, then the equation is ready for separation of variable. So for this number 5, this is also a variable separable problem. So if you are going to solve for number 5, do not use the solution for homogeneous equation, but rather you are going to use the solution for variable separable. In short, before you are going to use homogeneous equation, you must evaluate first the equation if that can be solved by an easier solution. That easier solutions refers to ready for integration or that is with the use of variable separable. Let us now proceed in finding the solution of a differential equation. By this time, I will give you 30 seconds to answer. I understand you need longer time, so you have the option to pause this video while answering, after which you can play back the video to check your answer. We're now going to solve the given differential equation. For our solution, the step 1, check if the equation has homogeneous coefficients. That means we are going to write the equation into this standard form. Our equation is y prime is equal to y over x minus y, where our y prime is equivalent to dy over dx. We are going to substitute now the value of y prime, that is dy over dx, and that is equal to y over x minus y. To convert to the standard form, we have to multiply this equation by dx, so that dx will become numerator. Likewise, I'm going to transpose x minus y to numerator, so I'm also going to multiply the whole equation by x minus y. And the product of the equation by this factor is x minus y dy, and dx here is cancelled. For this right member, x minus y is cancelled, and you have y dx. Then let us transpose our y dx to the left side. So you have here negative y dx plus x minus y dy, and that is equal to 0. You notice our dx term has a degree of 1. For our dy term, we have x variable here, the degree is 1, and also y variable, the degree is 1. So all coefficients have a degree of 1. Therefore, the equation is homogeneous. We will proceed to step 2. We will substitute either x is equal to vy or y is equal to vx. As I recall, if you are going to substitute x is equal to vy, you will substitute dx is equal to, use the product formula here, we have v dy plus y dv. Then, on the other side, if you will substitute y is equal to vx, we have here dy is equal to v dx plus x dv, using the product formula. As noticed, if you are going to substitute dx with this v dy plus y dv, you have y multiplied by binomial. But if you will substitute dy, the dy will become binomial v dx plus x dv multiplied by this binomial. So between the two, it is better to use x is equal to vy. So we are not going to use here the y is equal to vx. So we're now going to substitute x is equal to vy in our equation. Our equation is negative y dx plus x minus y dy is equal to 0, where our x is equal to vy. Then get the differential for this. You have dx is equal to v dy plus y dv. Now, let's substitute to this equation. You have negative y, and dx here is v dy plus y dv plus. For the second term, I'm going to substitute the value of x, which is vy. So we have vy minus y, and dy is equal to 0. As noticed in this line here, the variable y can be cancelled. Specifically, the first term has variable y, and the second term, y is common. So, we are going to factor out y in the second term. In this line, I'm going to copy the first term. We have negative y, v dy plus y dv. Then I'm going to factor out y, and we have the remaining here is v minus 1 dy equals to 0. Then multiplying the whole equation by 1 over y, this y here are cancelled. So we have now negative v dy plus y dv plus v minus 1 dy is equal to 0. I have to emphasize that in a solution of homogeneous, there's always a variable that will be cancelled in this line. It is either x or y. So after we cancel that variable, we can proceed to simplify the equation. I have to remove the parentheses here. The sign inside the parentheses will be changed. So we have here negative v dy minus y dv. And here, the parentheses is preceded by positive. So we have here plus v dy, then minus 1 dy is equal to 0. Then we are going to group the dy term. As you have noticed, you have here negative v dy here, and you have positive v dy. So these are cancelled. And the remaining is negative y dv and minus dy is equal to 0. So our homogeneous equation is now converted into a variable separable problem. For step 3, solve the obtained variable separable problem. This is our variable separable problem. We have here negative y dv minus dy is equal to 0. As noticed, we are going to transpose y to the other term. So we are going to multiply this equation by 1 over y. At the same time, you notice that both terms are negative. It is better if we can convert this into positive sign. So I'm going to multiply the whole equation by negative. But I have to emphasize that it is only my preference to multiply the equation by negative. You have the option to multiply the equation by positive 1 over y. But in my case, as I have mentioned, I have to multiply this by negative 1 over y. So let's do the multiplication. Negative multiplied by negative is now positive. Then y is cancelled, so you have here dv. Then negative times negative is again positive. Then we have dy over y is equal to 0. Then we are going to integrate the terms in the equation. The integral of dv is v. Then plus the integral of dy over y using the ln formula, that is now ln of y. Then equals to c. Then let's proceed to our step 4, back substitution. Remember, we let x is equal to vy. From this, we can solve now the value for v. In this equation, we are going to multiply this by 1 over y. So we have here x over y is equal to v. Then we are going to substitute our value of v to this equation. So we have now x over y plus ln of y is equal to c. And this is now our final answer. Hello everyone. This is the end of our discussion on equations with homogeneous coefficients. You can now proceed to our next video, which is the exact equations.